Hello everyone, this is Rashida. Welcome to my channel. My today's video is going to be on functional API. I will show you how to build TensorFlow model using functional API. Before we dive into the code, a little bit introduction. In my previous tutorial on TensorFlow, I always used sequential model. And in sequential model, each layer takes the input from the previous layer, except for the first layer. But in functional API, you have more flexibility. You can provide where the input should come from any layer. Multiple input and multiple output models can be defined, and multiple models can share one layer because each layer is its own individual object. So this is just a little bit of introduction. You will see all this in action when we will dive into the code. Yeah, let's dive into the code. And I am using California housing dataset, and you can simply import that from sklearn library. So it's going to be a regression model, and the dataset is pretty clean. Let's dive right into the model. Inputs tf.keras.layers.input. So input layer, typically we put shape. And you can see for the shape, you pass this number of columns that we have or number of training features. The next layer is going to be the dense layer. And you can see how we define each layer separately. They're totally separate and independent from each other. tf.keras.layers.dense. So I will use 128 neuron activation function ReLU. And here you can pass inputs, means input layer. Okay. So this is why this is called functional API. You can use this as a function and pass the parameter inputs. And we will keep it really simple. Outputs. Okay. tf.keras.layers.dense. Because this is a regression model, output model is going to be just one. And you can pass dense layer here. So that's pretty much the simplest model. We will see a little complex version a little bit later. So we developed all the layers. Now we build the model. Model tf.keras.models.model. And here you pass inputs and outputs. The outputs, that's what we defined here. Okay. After model development, as usual, we compile, passing the loss optimizer. I'm using Atom optimizer and matrix, root mean square error, and then model fit, we pass X train, Y train, we run it for 20 epochs. We're passing validation split 0.2. That means 20% of the data is going to be used as validation data. Let's run. Model training is done. Let's see the evaluation. So you can see the loss and our matrix root mean squared error. Let's see what happens if we develop this model a little differently. So first I will just copy the input layer from here because the input layer is going to be the same. So instead of calling it inputs, let's call it input layer just to make it a little bit more specific. Hidden layer 1, because we are going to have two hidden layers this time. tf.keras.layers.dense. I'm putting 128 and activation function ReLU again, and passing the input layer here. Hidden layer 2. Okay, let's copy this whole thing. So here I will put hidden layer 1 as input. Okay, I will develop a concat layer which will concatenate this hidden 2 with input layer so that our output layer is more connected to input layer. Okay, tf.keras.layers.concatenate, and then we pass input layer and hidden 2. Okay, this hidden 2. So we are concatenating them together before we develop output layer. And then output layer is going to be another dense layer, and we pass concat here. So when we pass concat here, what output layer gets? It gets a combination of hidden layer 2 and input layer. Let's see how the model performs this time. Okay, as usual, we will compile this model and using the same code. Now build this model again. Model 1, tf.keras.models.model inputs input layer outputs output layer. So model 1 is done. Now I'll just copy this compile. I will use exact same parameters. So model 1 I compiled, and then age model 1.fit extreme while train epochs 20 and validation split. Again 0.2. Let's run. Model training is done. Now let's model 1.evaluate. We will use the test data we have to evaluate the model. And if you notice, our loss and root mean square error both are much less this time. So it looked like we achieved better result using slightly complex trick. So please feel free to play with more layers, more different kinds of structure like that, and see if you can get better result than this. I hope you will try functional APIs for your model too. If this video was helpful, please like, comment, share, and subscribe. Thank you so much for watching.